Welcome back to TAE Certification Training Series. In today's session, we will continue with the TAS metrics. Let's start with the second external TAS metric, which is effort to build automation tests. Key cost in test automation. Automating test is a significant cost in test automation. Often, this cost is more than running the same test manually. This can pose challenges when considering expanding test automation. Okay, so think of the effort to build automated tests as a significant cost in the world of test automation. Sometimes it can even exceed the cost of performing the very same test manually. Now, this might sound a bit surprising because automation is supposed to save time and money, right? But the truth is, getting automation up and running can be a bit like investing upfront. While it can be costly initially, it pays off in the long run by making testing faster and more efficient. However, this initial cost can sometimes discourage organizations from fully embracing test automation and expanding its use. Then we have factors impacting costs. The cost of implementing an automated test depends on multiple factors. Let's go through them one by one. The first one is the nature of the test itself. So the complexity and scope of the test can influence the cost. Simple tests are like quick snacks, while complex ones are more like elaborate meals. Then we have the scripting approach employed. The method used to create the automated test scripts can affect cost as well. So choosing well-established scripts is faster than creating your own from scratch. Then we have familiarity with the test tool. So how familiar your team is with the testing tool plays a crucial role as well. Using tools you already know is usually more efficient than learning new ones. Then we have environmental factors. The stability of your testing environment matters a lot. A controlled, stable environment is more predictable and reduces potential hiccups. The skill level of the test automation engineer. The experience and skill of your automation team can impact costs. Skilled engineers are more efficient at creating and maintaining automated tests. Calculating build costs. Building automation for larger or complex tests often requires more time than for smaller, simpler tests. For example, let's say you have a set of tests to automate. Some of them would be short and simple, while others will be large and complex. The complex tests are challenging to automate because it requires greater investment of time and effort to develop automated scripts. Short or simple tests are relatively easier to automate because they are less time consuming. So computing the build cost for test automation may be based on an average build time. This means that when you are budgeting or estimating the cost of automating all these tests, you might calculate an average time it takes to automate a single test. For example, if you have a mix of simple and complex tests, you might find that on average it takes 2 hours to automate a test. So for budgeting purposes, you use this 2-hour average as the build cost for each test. It can also involve considering the average cost for specific sets of tests. The first one would be tests focusing on the same function. Okay, so to understand this, we will take an example. So let's say that you are in charge of testing a new e-commerce website and you want to automate your test effectively while staying on budget. Okay, so for this one, think of your website's checkout process. It involves various steps: selecting items, entering shipping details, and making payments. So you can create a set of tests specifically targeting this checkout function. These tests check if customers can smoothly complete their purchase or not. By calculating the average cost for this set of tests, you get an idea of how much it takes to ensure the checkout process works flawlessly. Next, we have tests at a particular test level. So we already did the test levels in the foundations level certification. So this means that, okay, so now consider testing at different test levels. By creating separate tests for each of these levels and calculating their average cost, you can effectively manage your testing budget for your e-commerce website, ensuring that every component from individual elements to the complete user experience is thoroughly examined and it satisfies your customers. So by doing this, you can allocate your resources based on what's most critical. So for instance, if checkout is a critical function, you can prioritize spending on those tests. Similarly, you can choose the right level of testing to balance thoroughness and cost effectiveness, ensuring your website is both functional and budget friendly. So to summarize, understanding these aspects of the effort and cost involved in building automated tests is crucial for making informed decisions about the adoption and implementation of test automation in projects. Comparison to manual effort. An alternative perspective is comparing automated test effort to manual test effort, equivalent manual test effort, EMTE. For example, it might require twice the manual test effort to automate a test case, or in other words, it's 2 times the EMTE. Okay, so let's try to understand it with an example. So let's say you have a test case for a software application that takes a skilled tester 4 hours to perform manually, as it's shown in this bar chart. This 4-hour effort is what we call the EMTE, or equivalent manual test effort. Now you decide to automate the same test case. However, the automation process is quite complex and it takes a test automation engineer 8 hours to create the automated script, set up the automation framework, and make it work flawlessly. In this scenario, the effort required for automation is 2 times the EMTE. It took double the time to automate the test cases compared to the time it would have taken to perform it manually. So this example demonstrates that for this specific test case, automation required more initial effort than manual testing. However, it's important to remember that the long-term benefits of automation, such as faster and repeatable testing, can outweigh this initial investment. Moving on to the third external TAS metrics, it is effort to analyze SUT failures. Analyzing failures in SUT discovered through automated test execution can be significantly more complex than for a manually executed test, because the events leading up to the failure of a manual test are often known by the tester running the test. So when we are dealing with automated tests and something goes wrong in the software under test, SUT, figuring out what happened can be quite a puzzle. It's trickier than when a human tester runs a test because they usually have a good idea of what led to any issues, but in the automated world, not so much. Mitigating complexity. This complexity can be mitigated as described in the design level in chapter 3.1.4, which we already covered, and in the reporting level in chapters 5.3 and 5.4, which we will go through soon. So these are insights on how to handle it at the reporting level. These strategies can help make sense of those failures. Then we have measuring effort. This measure can be expressed as an average per failed test case. Okay, so let's understand that what it is. So measuring effort, what is meant by this is that when we are trying to figure out how much effort it takes to analyze failures during automated testing, we have two options. And the first one is an average per failed test case. This means we calculate the average effort required for each individual test case that fails. So if you have multiple failed test cases, you would find the average effort needed to analyze each one separately. And the second one is a factor of EMTE. So in the previous metric, we did discuss that what EMT is. It's a way of measuring how much effort it would take to perform the same test manually. So when we talk about expressing something as factor of EMTE, we are actually figuring it out how much easier or harder it is do a task using automation compared to doing it manually. It's like saying that automating this saves us X times the effort it would take to do it manually. Now, why might you choose one over the other? Okay, let's see. The latter is particularly suitable where the automated test varies significantly in complexity and execution length. Okay, so well, if your automated tests are fairly consistent in terms of complexity and how long they take to run, expressing the effort per failed test case might be more straightforward. But if your automated tests vary a lot in complexity and execution length, then the second option, using EMT as a benchmark, can provide a more meaningful comparison. It helps you to understand how much time and effort you are saving by using automation compared to doing things manually. So it's about choosing the right measure that fits your testing scenario. Role of logging in analyzing failures. The available logging of the SUT and the TAS play a crucial role in analyzing failures. The logging should provide enough information to perform this analysis efficiently. In software testing, logging records all the actions and events, allowing us to review them later if there is an issue. So it's like having a digital security camera to investigate issues. Important logging features include SUT logging and TAS logging should be synchronized. Now, this means that they should have consistent timestamps and formats so that they can be easily compared and correlated. And this helps to determine the cause and effect of the failure and to avoid any confusion or any ambiguity. Then we have the TAS should log the expected and actual behavior. This means that it should record what the test case was supposed to do and what it actually did. This helps to identify any deviations from the expected results which may indicate a failure or a defect in the SUT. Next we have the TAS should log the actions to be performed. This means that it should record what steps or commands it executed on the SUT and what parameters or inputs it used. This helps to reproduce or replay a test case, which is useful for verifying the reproducibility of a failure or for capturing additional information. Logging by the SUT. The SUT should log all actions that are performed regardless of whether the action is the result of manual or automated testing. Okay, so this means that the SUT should keep a record of every action it takes, whether a human or a machine triggers it. In essence, it's like having a detailed journal of everything the SUT does during testing, without discriminating between manual or automated processes. This comprehensive logging helps in tracking and analyzing the SUT's behavior for testing purposes. Any internal errors should be logged, and any crash dumps and stack traces should be available. Okay, so now this means that if the SUT encounters any problems or errors while it's being tested, these issues should be recorded in a log. Additionally, detailed information about these errors like crash dumps. So now what are crash dumps? Crash dumps are which provide a snapshot of the program's memory at the time of a crash. And stack traces are which show the sequence of function calls leading to the error. So they should be saved and made accessible. So to summarize, strong logging practices and thoughtful analysis are critical for effective test automation and ensuring the reliability of the SUT. So we will wrap up our session over here, and we will continue with the remaining TAS metrics in our next session. Till then, take care.